I've been involved with cochlear from the day we began, and I'd like to tell you about our early times. But first, some of my background and some of that of Graham Clark. When I was quite young, I plugged in a toaster against the advice of my parents, but with the encouragement of my older sister that you see here, with my fingers across the pins of the plug. And I can still remember the tingling and the blister that caused. Then, when I was 7, I built my first crystal set, and using an antenna wire 100 feet long, I could hear the local radio stations. This was using the energy transmitted from the stations themselves and without a battery. When I was 18, I built my own amateur or ham radio, and I used this to talk to people all around the world. Now about Graham Clark. Graham was truly the forefather of the multi-channel cochlear implant. His father was a pharmacist who was severely deaf. Graham could hear him in his pharmacy asking his customers to repeat orders for very personal items, much to their embarrassment. So from when he was just 5, Graham knew that when I grow up, I want to fix ears. Well, Graham qualified as an ENT surgeon and then completed his PhD, with the concluding remarks, "If pure tone reproduction is not perfect, meaningful speech may still be perceived. Your speech can be analysed into its important components and these used for electrical stimulation. More work is needed to decide which signals are of greatest importance in speech perception." Graham was then appointed Professor of Otolaryngology at the University of Melbourne. And as you see in this newspaper article, his ambition was to bring hearing to people who were totally deaf. And from the very beginning, he wanted to help both adults and children. Well, the idea of electrical stimulation of auditory nerves to provide speech perception was considered impossible by expert physiologists at that time, as you see here in quotes from Lawrence and Fowler. Given the complexity of the auditory system, they were convinced that speech recognition using electrical stimulation was just not possible. Well, here's Graham explaining his plans for the cochlear implant research, just after his appointment. Unsurprisingly, the conventional research funding sources did not think that his research proposals should be funded, so different sources were needed. So Red Jansett, the part owner of an airline company and a television channel in Australia, seen here, had a child with a deaf friend, and he saw the impact of hearing loss on the life of the friend. So he arranged for several telethons that raised money to help pay for Graham's research program. Graham also established a Christmas fundraiser with volunteers collecting money outside Melbourne department stores. And here is a cartoon of Graham collecting. Well, here's a photo of Graham's research team in 1975. After 5 years, he put together a team of researchers working on auditory physiology, auditory nerve responses to electrical stimulation, electrode technology, audiology, and the development of neural stimulation electronics. The circles you see there are around Graham and myself. I was somewhat darker in those days. Following successful early projects, Graham had just recruited me to lead the development of a stimulator that was to be implanted in the first human volunteer. I had degrees in physics and almost in electrical engineering, and was looking for work that was more interesting than data transmission. At the end of my job interview, I asked Graham, "Do you think it'll work?" He said, "I don't know, but if it does, you may have a job." Well, for the implantable stimulator, it was a case of being in the right place at the right time. Electronics technology had just moved from transistors to integrated circuits, and using the latest custom chips, it was possible to make an implantable stimulator that was small enough to fit in the space available behind the ear. And here you see a mastoid bone with a drilled package bed just behind the cochlear and the round window through which the electrode was inserted. This is the layout of the custom integrated circuit that we developed, and the implant used 10 of these chips, one for each of our active electrodes. And here's my hand holding our Umdolly hearing prosthesis, containing almost 50 components on 3 substrates that you see here. These were stacked, interconnected, and sealed inside the gold-plated box. Power and data were transmitted using 2 coils outside the box. And we had some essential technology support from these companies in Melbourne. Well, our first volunteer was Rod Saunders, who'd been deafened in a car accident. And after 6 months of trying to lip read his family members unsuccessfully, he'd become very frustrated, and he joined us as a volunteer. Following his implant surgery, Rod came to the lab 3 days a week for many months. And after several months of testing, exploring hearing sensations that could be delivered using our multi-channel cochlear implant, here is a test session using our first speech coding strategy.
In the end. In the end.
In the
End.
head.
End. In the end. Put the coil back on. Put the coil back on.
Difficult.
Can you hear me now? Can you hear me now? Is it loud enough? Good. In the end.
In the end.
There was so much material.
There was so much material
Wrapped around his head.
wrapped around his head.
He could hardly keep his balance.
He could hardly keep his balance.
He was then given a revolver.
With the implant enabled, Rod could lip read, missing hardly a word. Well, using the video you've just seen, Graham lobbied the Australian government for money, asking for support for the development of a clinical device. And this is another case of being in the right place at the right time, as the Department of Productivity had just started funding projects that were thought to be in the public interest. They funded 2 more research subjects and a global market survey, together with an assessment of what it would take to develop a clinical cochlear implant system. Next, they funded the development of the clinical system and the implantation of 6 subjects for a pilot study in Australia. Well, the clinical implant was to be developed by a new group set up in the Nucleus company with the leadership team that you see here. I joined them as a technical transfer from the university. The photos are a little blurry because we had to move very quickly to meet Paul Trainor's target of a prototype system in just 12 months. As you see here, I joined Cochlear in August 1981. And here is our first cochlear implant using a modified pacemaker chip and some unique packaging technology that was intended to give the implant a long life. We recruited some very clever engineers, and this took us just 13 months to develop, one more than Paul's target. The pilot study with 6 subjects in Australia was successful, and we thought that it would be enough to attract venture capital, which we needed to fund our first international study in the United States. But unfortunately, it was seen as too risky to attract any venture capital funding. And this led to further funding from the Australian government for a US-based clinical trial, starting in 1983. And this is the first implant system, the implanted stimulator and electrode array, the external coil and microphone, with the coil being held in place over the implant using a wire frame. And then a cable joined the headset to the body-worn sound processor. Well, the clinical trial took place in a sceptical clinical environment, but we had an excellent team and the research centres, including leading surgeons and audiologists. The trial was not without its problems, but they were resolved, and there's no time here to discuss them. The FDA panel meeting took place in August of 1985, with one panel member commenting, "This is the best study that I've seen." And we received FDA approval in October 1985. Well, that was a bit of my history and the start of the 42-year journey of Cochlear. We're dedicated to supporting our recipients through their lifetime of hearing. As well as providing systems that have world-leading reliability, this means that we need to understand how the hearing health industry is changing. We must learn from our recipients what matters most in their daily lives, and we must continue to innovate to provide support for our more than 700,000 recipients around the world. The sound processors of today are smaller, smarter, and better connected. Smaller sound processors can offer more comfort and ease of use for whatever adventures life may take you on. Whether that's swimming, cycling, concerts, school, dining in restaurants, using a smartphone, or just watching television. Smarter technology may help recipients hear conversations more clearly and easily in noisy situations. And new technology may offer even better connection to the world through the next generation Bluetooth, such as Bluetooth, Auracast, and advanced smartphones. We'll continue to keep you, our recipients, your families and friends, at the focus of all we do as we look to the future. Thank you.